Hello guys, this is Mr. Minai. I want to share about my wonderful electronic circuits called the practical applications of the current divider. These circuits are very fundamental for all the electronics beginners and this also important for electronics projects. I will show you this with my circuits diagrams and my practical one. And this so let's see my circuits diagram first. Here you see this my circuits diagram show the current divider. This my power supply of the bodies of battery. This the resistance of the first resistor R1 and this the resistance of the second resistor R2. This the current passing through the first resistor R1 and this the current passing through the second resistor R2. As you see, saying the two resistors connect and parallel. Equal amounts of potential difference will pass through these two resistors. If we apply Kirchhoff's current law to the whole circuit, we have this expression I mass equal I1 plus I2. I mass maximum current pass through the whole circuit. I1 the current passing through the first resistor R1 and I2 the current passing through the second resistor R2. And this so if we replace an LED in place of this second resistor R2, we have another equivalent circuit like this. This RP, the resistance of the resistor connect and parallel with LED. This LEDs use in place of resistor R2 from the first circuit. This current, the current passing through the resistor RP. This IF, the forward current pass through the LED, and this so we can easily write for maximum current pass through the circuit. Imax equal IP plus IF. This Imax maximum current pass through the whole circuit. This IP, the current passing through the resistor RP, and this IF forward currents across the LED. And this so if we solve for IP equal Imax minus IF obtained. If we apply Ohm's law to this resistor RP, we have IPs divided by IPs equal VBs divided by RPs obtained. If we replace this formula in IP, we have VBs divided by RP equal Imax minus IF obtained. VB divided by RB equal Imax minus IF. If we use the reciprocity properties of equation, we have RP divided by VB equal 1 divided by Imax minus IF obtained. If we solve for resistance of the parallel resistor RP is equal VB divided by Imax minus IF. We must note in this equation that Imax greater than IF and VB is approximately equal VLED. And this so, if we take Imax approximately equal 10.1 milliamp for 12 volt 0.12 watts of LED, we can easily calculate the excess value of the parallel resistor RPS. RP is equal 12 volts divided by 10.1 milliamp minus 10 milliamp. This 10 milliamp, you know, the ratio of power of LEDs to its potential difference. Okay, and this so RP is equal 12 volts divided by 0.1 milliamp equal 120 kilo-ohm. This calculation shows that if we use 120 kilo-ohm resistor in parallel with an output LED, when our supply voltage is 12 volt, the maximum output current across that LED must be 10 milliamp. If we take Imax approximately equal 20.1 milliamp for the 12 volt 0.24 watts of LED, we can easily calculate the excess value of the parallel resistor RP like this. RP is equal 12 volts divided by 20.1 milliamp minus 20 milliamp. This 20 milliamp, you know, this is the ratio of power of LED to its potential difference. Okay, and this so RP is equal 12 volts divided by 0.1 milliamp equal 120 kiloohm. This calculation shows that if we use 120 kiloohm resistor in parallel with an output LED, when our supply voltage is 12 volt, the maximum output current across that LED must be 20 milliamp. If we take I max approximately equal 30.1 milliamp for 12 volt 0.3 watts or 0.63 watts of LED, then we can easily calculate the excess values of the parallel resistor RP is also the same value 120 kiloohm. This calculation also shows that the maximum output current across the 12 volt 0.3 watts LED is 30 milliamp. And this all you clearly understand. I will show you my practice was only for 12 volts and 12 volts unknown watt LED with the supply voltage 12 volt. Okay, you see this my practical circuit. You see this point. Positive terminal of 12 volt battery, one side of 120 kiloohm resistors and positive terminals of emitters are all together connect. You see this point. Negative terminals of emitters and outside of 12 volt LEDs are connect. This one you see another side of 120 kiloohm resistor, negative terminals of 12 volt batteries and cathode side of LEDs are all together connect. And this is a very important fact that you must be clearly understood in this circuit that the readings values of this emitter says emphasize the current divider values of this 120 kiloohm resistor based on the real maximum power of the 12 volt battery. Okay, and this so you clearly understand. Let's see my practical circuits. Here you see this my practical circuits. This 12 volt batteries. This my LED. This my 120 kiloohm resistor. This my emitter. Okay, and this so you clearly understand. Let's see my practical one. Okay, here you see the readings of my emitter 0.01 amp. Here you see my LEDs lightening are. Here you see my LEDs lightening are. Okay, here you see my readings of emitter 0.01 amp. Okay, a very important fact that you must be clearly understood in this circuit that the reading values of this emitters are emphasize the current divider values of this 120 kiloohm resistor based on the real maximum power of the 12 volt battery. Okay, and this so if you like me, please give me like and share to my channels and subscribe my channel. Thanks for watching.